game industry is massive and getting bigger every year. In 2010 already, 68% of the households in the US had a gaming engine. The average player is 35 years old and has 12 years of experience on average in playing games. Every generation plays, and plays quite a lot since the US national average is 150 hours per year per player. The age distribution of the players is surprisingly uniform, and about half of the players are female. The diversity of gaming experiences, including educational games and gamification of working tasks, is astonishing. The demand for new or player-customized game content keeps increasing, while manual production of high-quality content is expensive and not scalable. From the teams of 4 to 6 employees and 1 content developer that were common in the 90s, game development teams have grown to contain hundreds of people. For a contemporary commercial game, content developers make up 30 to 40% of the team. With production costs in millions of dollars, content development is both a financial and a product time-to-market bottleneck. In 2008, World of Warcraft had over 30,000 items, over 5,300 virtual creatures or characters, and 7,600 quests that were developed over 5 years. In this lesson, we will look at procedural content generation for games. Procedural content generation refers to the algorithmic creation of game content in an automated or mostly automated way. In other words, procedural content generation, or PCG, refers to generative software that can create game content autonomously, or together with human players or designers. What exactly do we mean by content in this context? Games are made of all sorts of content and exist in a wide variety of formats and experiences. Hendricks and colleagues propose a layered model in which upper levels of content use the content of lower levels. We distinguish 6 types of content. At the first, lowest level, we have game bits. Game bits are graphical content such as textures, vegetation, buildings, clouds, wind, fire, water, stone, and wood. Basic game rules and physics rules, some story elements, musical elements, and objects such as weapons and vehicles. At the second level, there is the game space, made up of indoor-outdoor maps, universe structure, and the content layout. The third level contains the game systems. These include ecosystems, road networks, and urban environments. Agents and characters also belong to this category. Non-player characters are in this category because they are agents, but they could also be considered game bits in some cases. The fourth layer is the game scenario, where you have games levels, plot, story, and narratives, puzzles, etc. Then the fifth level is the game design level. That includes the design of the game world, the design of the rules of the games, and the game mechanics. The game engine itself might be included in this category. The sixth level is the level with all the derived content such as news and broadcast, leaderboard, and communication around the game. These 6 levels encompass just about everything about the game, from the small details to the complete game and all its elements. In this lesson, we will just offer a brief overview and give some relevant pointers to procedural content generation. We will leave aside non-player characters and agents, as these were covered previously in this class when we studied agents and multi-agent systems. We also will not cover the research on building artificial intelligence systems and agents to play games at a human competitive levels, because these are rational problem-solving tasks, not creative tasks. Again, rational problem-solving tasks are tasks for which there is a clearly optimal or correct solution. For example, playing chess, poker, Go, backgammon, or Jeopardy are not creative tasks. These are rational problem-solving tasks, and we have systems that outperform humans for all of those games. In fact, there are very few logical or mind games in which machines do not outperform humans. It is useful to notice that coming up with an answer at Jeopardy is a rational problem-solving task. There is such a thing as a right answer. But coming up with a novel and interesting question at Jeopardy is a creative task. To put it simply, every dimension of modern gaming has been addressed using generative techniques. Procedural content generation relies on all the techniques we have studied so far in this class. This includes mathematical functions and models for computer graphics and physical models for sound and spatializations. Many other dimensions of games can also be captured with parametric formal models, be they deterministic or stochastic. Randomness is another family of tools that have been popular. Elite, from 1984, used a pseudo-random generator to compress a vast universe of 8 galaxies with 256 planets each. A pseudo-random generator, as we learned earlier, is a chaotic system, but is deterministic with a given seed. Another family of generative techniques that is used for procedural content generation is noise. We studied Perlin noise amongst others, and these are still very much used for many texture generation applications. Rule-based systems such as L systems, shape grammars, and generative grammars are used to generate vegetations, buildings, text, dialogues, stories, plots, and the behavior of characters or the progression of the story. Fractal systems and a host of spatial algorithms are used for textures and ornamentation, whether it is tiling and layering, grid subdivision, vectorization, or the use of Voronoi diagrams. Most artificial intelligence techniques in general have been deployed in the context of procedural content generation. Search-based techniques have been used for pathfinding and reasoning, and other techniques and architecture that we saw were related to agents and multi-agent systems, constraint satisfaction, and planning for both individual and collective behavior. On occasion, tools from artificial life have been used and integrated too. These include using cellular automata and generic algorithms to automate agent behavior, reasoning, and coordination. Virtual ecosystems are almost a gaming genre on its own, and machine learning techniques such as artificial neural networks and many other techniques have been used. We saw examples of all these applied to gaming throughout this course. Historically, procedural content generation was born in the hacking and demo scenes of the 80s when random access memory was a limiting factor. Rogue is a 1980 dungeon crawling game in which levels are generated every time a new game starts. Given the lack of memory, procedural content generation was the only way to offer diversity to the players. Rogue started on monochrome screens of Unix stations, as you can see here. Then it was ported to IBM color screens. Finally, it was ported to the Atari ST, where actual raster images with computer graphics were introduced. Eventually, memory got cheaper, but procedural content generation continued, as it is one of the best sources of diversity and variety in games. Developing levels by hand is labor-intensive and time-consuming. In 2000, games such as Diablo 2 used procedural content generation to create maps and to create and place game items and monsters, just like in Rogue. And while memory is cheaper, size is still an issue sometimes, for example, for streaming or for playing on mobile phones. The 2006 game Krieger is a 3D first-person shooter that makes ample use of procedural content generation. It fits in 96 kilobytes, while it would have been taking 200 or 300 megabytes if it was not using procedural content generation. In fact, a single screenshot of the game is probably more than 100 kilobytes. There is also an element of developer pride and a desire for developers to display the skills that drive procedural content generation. The history of video game development is filled with computer science feats. Procedural content generation is most often used to produce game bits and other elements from the first few layers of the content model, while humans are still in charge of the storytelling and game mechanics. Minecraft is a 2009 game that is the second most sold game ever after Tetris. It revolves around procedurally generated three-dimensional universes. The topology of the maps and the universe generated is determined using a three-dimensional Perlin noise. But generative principles and systems are also used as game mechanic elements now and then. For example, evolutionary ecosystems are a central feature in Spore, a 2008 game we mentioned earlier, where the creatures that the players design are animated using procedural animation techniques. These personalized creatures are then used to populate a procedurally generated galaxy, and the evolutionary process drives the narratives of the game. The generation can be online or offline. Offline generation allows us to generate content ahead of time and is useful in the context of computer-assisted content design to generate maps, textures, and levels that the creative staff can work with. With online generation, we add time constraints, but we also allow the generated material to interact with the game content for a more customized player experience. In Left 4 Dead, a very popular first-person shooter game for 2008, the player behavior and stress level are analyzed in real time. An artificial intelligence director uses this information to tune the game state by controlling the parameters of the procedurally generated content in real time. Interactivity and generativity works hand in hand in that case. The players themselves can be used as designers or content providers sometimes too. In Spore, players can edit and exchange creatures. Here is a table presenting further examples of games and what level of the game content layered model they automate. In conclusion, procedural content generation automates the creation of some of the game's assets. It has obvious advantages because it offers boundless diversity and allows us to generate content that is relevant to the situation in the game, to the player, and to the context at a given moment. Video games are the perfect application domain for the type of algorithm used in generative art and computational creativity. The potential to make any or every part of a game through generative means is real. Sometimes, procedural content generation is economically motivated, but we also saw that it can influence game mechanics and improve the gaming experience by making games more adaptive, more rich, and more open-ended. Despite all these successful examples, the game industry is moving quite slowly. The primary ingredient that is needed in order to bring more generative technology into the games is people. People who are trained into both the creative and the computational side. People like you.